G'day, welcome to our second and final lesson looking at the Group 2 elements. Today's lesson we're looking at further reactions and uses of Group 2 compounds. For our lesson objective, we're going to understand the trends in chemical properties and some of the uses of Group 2 compounds. As always, the learning outcomes from the Cambridge curriculum we will be addressing. So we introduced last lesson the idea of our Group 2 elements found in Group 2, each having 2 electrons in the s valence most orbital. And we saw there were trends in both the physical properties as you go down the group and also in terms of their chemical reactivity and the chemical reactions that they undertake. We're looking at a little bit more depth at the chemical reactions that they can undertake and the chemistry of the compounds that will form as a result of that. So we said the chemical reactivity increases as you move down the group. We'll focus today on some further reactions of the Group 2 compounds and investigate some uses. So let's kick off by looking at some reactions with water. We looked previously at how magnesium reacts with water depending on the temperature, where if we have cold water, we'll have a slow reaction where we have magnesium hydroxide being formed and hydrogen gas effervesced. If we have a higher temperature where we have the water in the gaseous form, so we have steam essentially, it's going to be a much faster and a much more vigorous reaction when we form magnesium oxide as opposed to the hydroxide, and we still effervesce hydrogen gas in both instances. We said that due to the ionization energies decreasing as you go down the group, it means that the chemical reactivity will increase as you go down the group because it's easier for those larger atoms in group 2 to lose their electrons compared to the smaller ones. So let's consider what might happen with water as we go down the group. Here's a question. I want you to pause, have a think, write a reaction, and see if you have the answer correct. Write a reaction for the reaction of strontium with cold water. So use the example up here, which I've got for magnesium, just substitute strontium in. Do you expect it to be more or less vigorous than a reaction with barium? Tell you the answer now. So quite simply, if we've got cold water, we've got our water in the liquid phase, we react the strontium with it, we form the hydroxide and the hydrogen gas, 2 waters to balance all of that. Now, would we expect it to be a more or less vigorous reaction compared with barium? So the one that is further down has a higher chemical reactivity. So therefore, we would expect the barium to be the more reactive one compared to the strontium because it's a further period down. So the reaction with barium would be the more vigorous one. So therefore, the strontium would be less vigorous when compared to the barium. Okay, let's investigate some of the solubility of our Group 2 compounds. Let's look first at the hydroxides. This is something that we touched on at the end of last lesson, but now we're going to go into a little bit more depth. So I have the solubility of the Group 2 hydroxides. You can see we've got the atomic number down the bottom. So we've got the beryllium hydroxide, magnesium. No, we start at magnesium hydroxide rather. Then we have calcium hydroxide. Then we have strontium hydroxide and barium hydroxide. Let's talk about solubility. So if we have our hydroxides, let's do an example such as, let's go strontium hydroxide. We just did that one, so that would be a good one to start off with. So when we talk about solubility, we're talking about dissociating the ionic compound into the respective ions. So the aqueous, so we put it with water, and the 2 hydroxides in the aqueous form. Now we said that the Bronsted-Lowry definition of a base is something that can accept a proton, and our hydroxide here, this is the species that is going to be able to act as the Bronsted-Lowry base. So therefore, if we have a higher concentration of hydroxide, we have a more alkali solution, therefore we're going to have a higher pH. So the more this dissolves, the more soluble that the hydroxide is, it means we will have more of the hydroxide ions in solution because there's more has been dissociated from the metal hydroxide, the Group 2 metal hydroxide. So if we see here, if our solubility is increasing, it means our concentration of the OH- in solution is getting larger with an increasing solubility, we're forming more of it. Therefore, we will see an increase in the alkalinity as we go down the group due to this solubility. More soluble means a higher concentration of hydroxide ions, therefore more alkali, and a higher pH. Solubility increases as the energy holding the ionic lattice together, the lattice energy, decreases down the group. This isn't something we need to look at in any sort of depth just at this moment. but we can consider, if we're breaking down the ionic compound, how tightly held this lattice is. The lattice energy essentially is going to dictate how easy it is to dissolve. Now let's contrast that with not the group 2 hydroxides, but let's look at the group 2 sulfates. And what we see is the opposite. They are becoming much less soluble as we go down the group. So for our sulfates, our group 2 sulfates, the solubility decreases as we go down the group. Again, this is due to the strength of the ionic lattice. We don't need to be able to explain why this is occurring at this point, just need to learn the general trends. But it's all to do with the relative size of the cations and the anions to one another, if that is something you are interested in. Let's look at another type of a group 2 compound, which is our group 2 carbonates. A reaction of a carbonate with a dilute acid is something that you potentially might have seen before. So our group 2 carbonates, they're insoluble in water, they won't dissolve, but they will react with an acid. Metal carbonate and an acid has this general reaction where you form a salt, water, and you effervesce carbon dioxide gas. Here's a question. Pause and give this a go. Write an equation based on this general equation showing the reaction of magnesium carbonate with dilute sulfuric acid. So your metal carbonate is your magnesium carbonate, your acid is sulfuric acid, H2SO4. Give that a pause, see if you can work out the salt, and then balance it. And the answer will be this. Solid magnesium carbonate reacts with aqueous sulfuric acid to form magnesium sulfate, water, and carbon dioxide. Now, depending on the solubility of the sulfate, because you can see here that the salt we're forming is a group 2 sulfate, and we just discussed in this very previous slide the solubility of the group 2 sulfate. So depending on which group 2 element you're using, you're going to have a different solubility on this salt that's formed when you react a group 2 metal carbonate with sulfuric acid. Depending on the solubility of the sulfate, you can produce an insoluble sulfate layer on the carbonate. This prevents any further reaction because you have an insoluble layer on it and you're doing it in a wet chemistry in a water solution. So this will prevent any further reaction. Whereas if we're forming the nitrate or the chlorides, they're all group 2 salts. These are all soluble if you use hydrochloric acid or nitric acid, so you won't have this issue. Now we can also discuss thermal decomposition of the group 2 carbonates and nitrates, because these will be reactions that we can write for our group 2 compounds if we have a carbonate or nitrate. Thermal decomposition. Decomposition means that you are taking one thing and you are decomposing it, you're breaking it down into multiple things. Thermal just refers to heat. So it's essentially you're just heating something up to break it down into multiple products. Breakdown of a compound through heat. Carbonates will break down into a metal oxide and they will release carbon dioxide gas. Your turn for another go at a question. See if based off this information, you can write an equation to represent the thermal decomposition of calcium carbonate. So your carbonate decomposition, only one thing, break down with heat to form a metal oxide and release carbon dioxide gas. Give that a red hot try and I will tell you the answer here. Pretty simple, calcium carbonate, you're going to react with heat. You can write heat above the arrow to specify that it's thermal decomposition. You form a calcium oxide and carbon dioxide, and that is all balanced there. Group 2 nitrates undergo a similar thermal decomposition. This time instead of the carbonate, we have the nitrate and we form the oxide, but we also produce toxic nitrogen dioxide gas and oxygen as well. As you move down the group, both the nitrates and carbonates require higher temps due to their thermal stabilities. So that's another trend that we can summarize for our group 2 compounds. As we go down the group, they become more stable in respects with the nitrates and the carbonates, so they require higher temperatures because they have an increased thermal stability moving down the group. Finally, for today, to finish off this unit, we're going to look at some of the uses of our group 2 compounds. It is very useful for us to think, just outside of a purely academic understanding of our science and chemistry, how we can apply these concepts and these materials to our real world everyday uses that make our lives what they are. That's some of the uses we're going to look at now. Limestone is principally made up of calcium carbonate. These are found naturally in all sorts of rock formations, such as limestone cliffs or in caves. But it is a very useful building material, to use in marble, to make concrete, which we're going to look at in a bit of depth in just a moment, in the buildings of road, etc. So we can thermally decompose, and we just saw this reaction of calcium carbonate to make something called lime, which is just our calcium oxide. So often in everyday vocabulary, there are sort of common names for things that don't follow our specific scientific names that we know. And we do have to learn some of these in some of these instances. So for example, here we need to be able to recognize limestone, meaning calcium carbonate, and lime or quicklime, meaning calcium oxide. But this calcium oxide, this lime, is roasted with clay and you can make strong concrete. Also used in many other processes, production of steel, glass, organic chemicals, many other industries, a very useful thing, this lime. Then from the lime, we can form slack lime, which is just calcium hydroxide, by adding water. We saw this reaction, or an example of this type of reaction with the group 2 hydroxide earlier on. This has many uses as well. In agriculture, this is an alkali. This will neutralize the acidity if we have something like acidic soil, which isn't good for our crops to grow in. We can increase the pH to make nice soil conditions to grow lots of crops. Also in water treatment in the food industry, a very useful thing. So another compound we need to know by the common name, slack lime, calcium hydroxide, lime or quicklime, calcium oxide, limestone, calcium carbonate. We need to be familiar with those three things. One last question to finish off. Let's see if you recall, what is the equation to show the formation of slack lime? We looked at this earlier. It's just using our common names instead of our, specific chemistry names, and the reaction would be that calcium oxide plus water forms our calcium hydroxide. And we have finished another lesson and another unit. What have we done? We've described the reaction of the elements with dilute acids. We looked at these in more depth in the previous lesson. Described the behavior of the oxides, hydroxides, carbonates with water and dilute acids. Describe the thermal decomposition of the nitrates and carbonates. State the variation in solubilities of the hydroxides and the sulfates. And right at the end there, we just described and explained the uses of calcium hydroxide and calcium carbonate, powdered limestone in agriculture. For this lesson, you can pause and work through these tasks to consolidate your understanding. Excellent. That is another unit finished. I will see you on the next video when we start a new unit. Have a great one. Bye-bye.